All right, so let's look at some probability now. So the study guide in 11.1 says you got to do probabilities that are not conditional. Okay. All right, so I marked a few things off of our second test that were that type of thing. So, for instance, if you had a spinner and it was, white, white, gray, and black, all equally likely, and they said, what's the probability of getting white? You would look at how there's 2 regions that are white out of the 4 regions. That would be 1/2. Okay. All right. Another one that would be probability that's not conditional would be the one, that was question number 13 on the test. Okay. One like question number 15. In a hybrid corn research project, 150 seeds were planted, and 120 of them germinated. That means they started growing, they sprouted. Okay, and find the empirical probability that a particular seed of this type will germinate. So 120 germinated out of 150. You reduce that. And when you do, let's see, 3 goes into both of those. So that would be 4/5 when you get finished. Okay, so that's probability that is not conditional. Another one we did from the test that was like that. I'm trying to get a little more paper. It would be one like number 16, where you roll a couple of die, okay, and you're supposed to answer questions like, what's the probability? So roll 2 die. Okay, and then you have probability questions like, what's the probability of getting a sum? And I had on the test less than 5 on one version, less than 5. Okay, so you'd have to think about the possibilities, right? That product table really helps. And sometimes you want to see the actual what you got on each die. So you might have like 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, right? Is the actual outcomes. And then you need the sum. So you would imagine the sum of those. All right. So I don't really have time to complete the whole table on the video, but just to give you the idea, how it would work. I'm just going to do the part that's necessary. And we could keep going. And then here it would be 4 2. We could keep going this way. We could fill the whole thing in, but we're looking for getting the probability of getting a sum less than 5. So 5 would have been occurring right here, 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 and here. Less than 5 then would be these possibilities. So that's 1, 2, 3, 4, 5, 6. I can literally count. There's 6 of them out of, and there would be 36 possible outcomes. So you have a 1 out of 6 chance of having the sum of the numbers on the 2 die being less than 1/6. Okay. And I could ask all sorts of questions related to that. Okay? But that's what they mean, I think, finding probabilities that are not conditional. Right? And then we had the odds one. We did an example like that. So let me just, I think we did the one that was on the test. I can't remember. We'll go ahead and look. So if you have, I think I rushed everything we did on it anyway. So let's suppose you had 9 red marbles, 3 blue ones, and 6 yellow ones. And then what if I wanted the odds in favor of getting a red or blue marble? Okay. Odds in favor of getting a red or blue marble. So you're used to probability, right? If you did probability of getting a red or blue, you would add those up. 12 of the marbles out of 12 plus 6 out of 18 would be the probability, right? And this is what you'll get it confused with. So that would be a probability would be 2/3. But the odds would be, odds in favor would be 12 to 6. So this is in favor, this is against. So whatever they're stating, whatever the statement is, the odds would be 12 to 6, right? And now that actually can be reduced. It's like a ratio of 12 to 6. You could reduce that. It's, the odds are 2 to 1, right? If you simplified that. So you could say 12 to 6 or 2 to 1, right? The odds, not probability. They wanted odds. So you'd have to think about it that way. All right. And then another one I did was odds against getting a blue marble. Okay. So that's what you're looking for. That's what you want to have happen, is not getting a blue marble. Against getting a blue marble would be 15 to getting a blue marble, which is 3. And that can be simplified by dividing by 3. So it would be 5 to 1 odds. Okay. All right, let's do one more odds problem that I highlighted. All right, if the probability an identified hurricane will make a direct hit on a stretch of beach, the probability, so if we know that the probability of something is 0.25, what are the odds? Okay. So what you could do there is, if the probability is 0.25, you might think about that as being 25 over 100, or you might have recognized it as 1/4. So the odds would be 1 to 3. Okay. Oh, odds. I didn't finish the statement. What are the odds against? Okay. This is probability of getting a direct hit. And you were asked, what are the odds against a direct hit? Okay. So this is the probability of a direct hit happening. Okay. So the probability against it would be 3 to 4, but you want the odds against it. So it would be 3 to 1 would be your answer. The odds against a direct hit would be 3 to 1. Okay. All right. So then it talks about the other thing that was on the test that it says you need to know is expected value. So let's look at expected value problems. All right. So, all right, there was one on the test was number 24, where you had a chart. You had the number of absences on a particular day, and then you had this chart of what the probability would be. So no absences, 1 absence, 2, 3, 4, or 5. Okay, and then it gave you these values. Okay, so we had this table given to us with these various probabilities for each number of how many people would be absent on a particular day. Okay. And those, by the way, will all add up to be 1 if you add them up. Okay, so what you do for expected value is you're kind of doing a weighted average that would tell you how many absences, the number of absences to expect on a day. So you would multiply, you would do 0 times 0.06 plus 1 times 0.12 plus 2 times 0.20 plus 3 times 0.31 plus 4 times 0.14 plus 5 times 0.17. Okay. And then you'd work all of that out and see what that would turn out to be. So you would just do all of that on your calculator, and we get 2.86. So what that says is, on average, we would expect 2.86 absences in class. Okay. All right. And that's the section 11.5. So your second test had chapter 10, and then it had 11.1, 11.2, and 11.5. So those are the types of things I think we'll see when you go in and look at the problems on the study guide. Okay.